Welcome to our competency-based question series, designed chapter-wise to enhance your conceptual learning and two charge sheets having density 2 sigma and minus sigma are placed parallel and close to each other in a vertical plane as shown in the figure. Particle having positive charge Q and mass m is placed between these sheets and released from rest under gravity. What is the acceleration of this particle? So we have been given two charge sheets and there is a charge particle Q with mass m. It is placed somewhat over here and then it is released under the effect of gravity. So there will be two forces that will be acting on this charge particle. So first is due to gravity. So force acting on charge particle due to gravity, that is equal to Fg is mass of the particle, that is m, multiplied by acceleration due to gravity. And second force is acting on the particle is because of the electric field that is existing due to these two charge sheets. So electrostatic force acting on the charge particle, it is Q times the electric field at this point. So Fe is equal to QE. Now we need to find the value of electric field at this point. And we know that due to a charge sheet, the electric field is independent of the distance from the sheet. So it can be calculated as sigma upon 2 epsilon naught, that is the value of electric field due to this negatively charged sheet. And due to this positively charged sheet, the electric field, that is E2, it can be written as 2 sigma upon 2 epsilon naught. Now we need to find the direction of these fields as well at this point. So we know that the electric field due to a positively charged sheet, it is directed away from the sheet. So this is the direction of E2, that is field due to this positively charged sheet. And the direction of electric field due to a negatively charged sheet is directed towards the sheet. So this is the direction of E1, that is field due to negatively charged sheet. And we can see that both the electric fields, they are pointing in the same direction, and hence we can find the net electric field E as the sum of these two electric fields. So E, that is equal to E1 plus E2, it will be equal to sigma upon 2 epsilon naught plus 2 sigma upon 2 epsilon naught, and it is equal to 3 sigma upon 2 epsilon naught. This is the value of E. We can put this value of E in this equation, that is equation number 2. So Fe is equal to Q times thrice of sigma upon 2 epsilon naught. This is the value of force on the charge particle due to the electric field existing at this point because of these two sheets. Now the net force, F net, acting on the charge particle, it is the vector sum of these two forces. The force due to the gravitational field or the force due to gravity, it will be acting in the downward direction. And since it is a positively charged particle, the electric field that is in the direction of negatively charged sheet, it will be taking the particle in the upward direction. So the net force will be the difference of these two forces. So F net can be written as Fe minus Fg. So further we can write it as 3 sigma q upon 2 epsilon naught minus mg. This is the net force acting on the charge particle. And we all know by Newton's law, the net force, it is mass multiplied by acceleration. F net is equal to mass of the particle multiplied by the acceleration produced in it. So we can equate this equation to MA. So what I can write? 3 sigma Q upon 2 epsilon naught minus mg, it is equal to MA. So A will be equal to 3 sigma Q upon 2 epsilon naught m minus g. And this is the value of net acceleration experienced by the charged particle. So this is the final value, and it can be positive and negative depending on the magnitude of force due to gravity and the force due to the electric field. So if it is negative, then it means the charged particle is moving towards the negatively charged sheet because the acceleration is negative. And if it is positive, then we can say that it is moving downwards due to force of gravitation. And that's the answer for this question. Keep learning, keep practicing, keep excelling.